In this problem, we have a beam supported by a ball and socket joint at point A and a single journal bearing at point B. It is subjected to two concentrated forces, 200 Newton here and 300 Newton here. And we need to determine the support reactions at point A and B respectively. So the coordinate system is already chosen for us. So we have our X, Y, and Z axes. So the first thing we want to do is to draw the free body diagram. So we sketch out the beam. And then it's subjected to the 200 Newton force along the negative Z direction and 300 Newton force along the negative X direction. And then we need to sketch out on this free body diagram the support reactions at point A and point B. And we do that by identifying what kind of support it is, as well as what kind of constraints it provides. So at point A, because it is a ball and socket joint, it allows rotation about all three axes. Therefore, it does not provide couple moment support, but it does not allow translational motion in any direction. Therefore, it provides force supports along X, Y, and Z direction. So we have our AX unknown here, and then AY here, and then AZ here. At point B, we have a single journal bearing. If it is used alone, or if it's used with something that does not provide a lot of constraints, for example, a cable, then at the single journal bearing, we would have overall 4 support reactions. We would have force along the X direction, force along the Z direction because it prevents translational motion in these two directions, but also we would have a couple moment about the x-axis, as well as a couple moment about the z-axis, because it does not allow rotation about x and z axes either. However, in this case, because the single journal bearing is used together with the ball and socket joint at point A, and the force components at point A and point B would already form the couple moment to prevent rotation. For that reason, we do not need to consider the couple moment supports at point B. Therefore, at point B, we would only have 2 support reactions. That will be BZ and BX. So at this point, we have completed the free body diagram. We have overall 5 unknowns, and we know that with one 3D rigid body free body diagram, we can solve up to 6 scalar unknowns. So it looks like we will be able to solve this problem. So as you can see, because we have 3 unknowns at point A, therefore, even if the coordinate system was not chosen for us before, then if it's up to us to choose the coordinate system, we still want to have the origin of the coordinate system at point A, because that way we have the maximum number of unknowns passing through point A, passing through the origin. Therefore, they do not show up on our in our moment equilibrium equations. So that makes our calculation a little bit easier. So with the free body diagram down, let's start writing our equilibrium equations. So for this problem, we're going to use a scalar approach. Resultant force along the x direction equals to AX plus BX minus 300, that equals to 0. Resultant force along the y direction equals to AY, and that's the only one along the y direction, and that is already 0. Resultant force along the z direction equals to AZ plus BZ minus 200, and that's 0 as well. And then resultant moment about the x-axis. X-axis is right here. So AX, AY, and AZ, they don't have any moment about the x-axis. Bx is parallel with the x-axis, therefore it does not have moment about x-axis either. So Bz, same thing with the 300 Newton force, therefore only Bz and the 200 Newton force have moment about the x-axis. Bz creates counterclockwise rotational effect about the x-axis, so positive Bz multiplied by the moment arm is from here to here, that's 8 meters. And then the 200 Newton force creates clockwise rotational effect about the x-axis, so negative 200 multiplied by the moment arm of 6 meters equals to 0. And the next equation would be the resultant moment about the y-axis, but none of the forces has moment about the y-axis because all of them intersect with the y-axis. Therefore, we actually don't even need to write that equation. So we move on to the resultant moment about the z-axis. Same thing, ax, ay, and az don't have any moment about the z-axis. The 200 Newton force and the Bz force, they are both parallel to the z-axis, so no moment. Only Bx and the 300 Newton force have moment about the z-axis. So Bx creates clockwise rotation, so negative Bx multiplied by moment arm, again 8 meters. 300 Newton force creates counterclockwise rotation, so positive 300 times moment arm of 12. So that equals to 0. So overall, we have 5 equations, and we only have 5 unknowns. From there, we can solve for all of them. So we already know that ay is 0 from here. From this equation, we can solve for Bz, which equals to 150 Newton. From this last equation that only has one unknown Bx, we can solve for Bx. We substitute Bz into this equation, we can solve for Az. And we substitute Bx into this equation, we can solve for Ax. So we can solve for all our support reactions. And that's the end of this problem.